Welcome to The Explainer. Today we're going to talk about a pretty wild idea that most of a mine's environmental and social disasters are basically locked in before anyone even breaks ground. And the solution might just come from an unexpected place: 1960s Japanese shipbuilding. So let's just start with one number: 75%. Now, this isn't a good number. This isn't a profit margin. According to researchers, this is the percentage of a mine's future environmental and social risks that are decided, set in stone, from day one. And this very number is at the core of what a lot of researchers are now calling the 75% problem in mine design. Honestly, wrapping your head around this is absolutely key to understanding where the entire mining industry is headed. Yeah, so researchers took a page out of the NASA playbook, the same kind of systems engineering they use to keep spacecraft from blowing up, and they applied it to mining. And what they found was that 3/4 of the really big risks, we're talking environmental, social, and governance, or ESG, get baked into the plan right at the very beginning. This all happens way back in the conceptual phase, long before a single piece of equipment shows up on site. And here's the real problem, as Dr. Mike Naring puts it. See, engineers are amazing at modeling technical stuff, rock stability, equipment failure, that kind of thing. But ESG risks, that's a whole different ballgame. How do you put a number on community relations, or the impact on a local water source, or what the public is going to think? You really can't. And those very issues have become the number one reason these huge projects get delayed or even shut down completely. Okay, so if we know the risks are locked in so early, what are the big companies doing about it? And, more importantly, what are they missing? Where's the gap in the plan? Well, if you look at how the big players do things, like mining giant BHP, it all looks pretty logical. It's a 3-step process, right? First, you figure out who the stakeholders are: the community, investors, government, and what they care about. Then, you analyze a bunch of different ways to build the mine. And finally, you pick the best option. Seems pretty straightforward. But here's the catch. Researchers found this massive gap in the process. There's just no clear, structured way to connect those big picture values from step one, things like we want clean water or we want local jobs, with the nitty-gritty, super technical decisions the engineers are making in step two. And we're talking about the really crucial engineering levers here, the actual decisions about how you're going to mine, how big the operation will be, what the schedule looks like. These are the things that actually determine the mine's impact on the world. But those high-level community values, they were getting completely lost in translation before they ever reached the engineering department. So, to fix this, to bridge that gap, the researchers looked to a really powerful tool from a completely different world, and they used it to build something they call the House of ESG. Now, the whole approach starts with a field called systems engineering. And really, this is just a fancy way of saying you have a method for dealing with insane levels of complexity. I mean, we're talking about the kind of thinking you need to design a spaceship or plan an entire city. It's all about seeing the entire system, the whole shebang, not just the individual little pieces. And within that world of systems engineering, they grabbed a specific tool called Quality Function Deployment, or QFD. Now get this, it was first pioneered by Mitsubishi shipbuilders back in the 60s. Their goal was to figure out a systematic way to turn what customers said they wanted into the actual engineering specs for a better ship. The absolute genius of this QFD method is that it's basically a big matrix. On one side, you have the what's, that's all the values and needs of the stakeholders. And on the other side, you have the how's. Those are the specific, technical engineering choices we were just talking about. It literally forces you to draw a direct line between what a community cares about and what an engineer decides to do. And when you put it all together, you get the House of ESG. It's not just a chart, it's a visual roadmap. It lets anyone, an investor, a community leader, a regulator, trace a line from a big, important value like protecting our water directly to the engineering lever that's going to make or break that promise. So let's take a quick tour of this house. The main part, the rooms, is a big grid that shows you just how strong the connection is between a specific design choice and a stakeholder's concern. But the really brilliant part, that's the roof. The roof visualizes the trade-offs. It shows you how choosing one technical solution might actually mess with, or maybe even help, another one. And this is where the whole game changes, because this framework moves the conversation away from trying to find one single perfect number, and instead, it forces an open, transparent discussion about the trade-offs that have to be made. As Professor Peter Knights points out, you just can't boil all these
super complex ESG issues down to one simple financial number, like net present value, which is just a fancy way of calculating how profitable a project will be. I mean, trying to do that just hides all the really important compromises and choices that people need to be talking about.
So instead of one number, the framework lets you see different scenarios side by side. So imagine a chart that shows option A gives shareholders a little more money, but it's a terrible outcome for the local indigenous communities. Option B, on the other hand, is a much better deal for those communities, but it means a slightly smaller return for the shareholders. See, this tool doesn't spit out the right answer. What it does is force everyone to have the right conversation.
So what we're really talking about here isn't just a new chart or a new process. It's a whole new blueprint for how you even begin to think about designing a mine, right from the very first conversation.
So, what does this house of ESG really accomplish at the end of the day? Well, for one, it takes a ridiculously complex problem and gives it structure. It creates that clear line of sight from a single engineering decision all the way back to the person who's going to be affected by it. It gets everyone, from the engineers in their cubicles to the community members in a town hall, on the same page. And maybe most importantly, it puts the tough trade-offs right there on the table for everyone to see. It basically creates a shared language for a conversation that's been almost impossible to have until now. And that really leaves us with one last big question. For decades, the mining industry has gotten incredibly good at engineering for profit. The question this framework really asks is, do we finally have the blueprint to start engineering for people and the planet too?